I will try to be short, but yeah. Exactly, yeah. But yeah, well, and yeah. Okay, so I will just report quickly on the discussions we had yesterday between the CAMS 235 and CAMS 273 teams. Marion will correct me or complete if I forget some items, of course. It was so short, I mean, let's say, it was only 2 projects. So we discussed a lot, but it's a small session as compared to what we saw, for example, this morning. And there was only 2 presentations. So I will just summarize quickly the presentation. So basically, if Marie presented this tree and the future plans of the MacClear chain, which Marion also mentioned here. Basically, the current version uses simulated mass mixing ratio of aerosol species and then map them to the opaque species, which are different species than what we use in the IFS, so as to be able to use the opaque optical properties, which are widely used by quite a lot of people. The plans, as Marion said, is to move actually to direct output from the IFS, so AOD, single scattering albedo, and asymmetry parameter, and they use maybe some vertical scaling height or anyway some vertical information from the IFS in MacClear version 4. And I presented some evolutions in dust modeling in cycle 48R1, which clearly impact quite a bit what you're doing in radiation services, and further plans with respect to dust optical properties, and also, more broadly about dust optical properties. And beyond this, we discussed, let's say, further ways to cooperate or collaborate and exchange data. So basically, what came out of it in terms of action items and outlines is that CAMS 273 is keen to use and to get access to the aerosol optical properties that we're using in the IFS, the mass extinction SSA from each aerosol species, so as, of course, to check what we're using, but also to compare them to opaque data, so we can see how different what we do is compared to opaque. Of course, we, CAMS 235, are interested in feedback from CAMS 273. Sorry, I forgot 172. On what we are doing with respect to aerosol optical properties, and of course, the feedback from your evaluation, because that's very important to us to see the changes that we bring, if they are positive or negative to your chain, to your results. CAMS 273 is asking about if it's possible to develop or produce an AOD above boundary layer product. That's to be discussed probably more with ECM-DRF. I mean, that's not something. The interesting thing about this possible evolution of the MacClear algorithm is that then single scattering albedo and asymmetry parameter would become much more important products. I mean, right now they are produced, they're archived, and we look at them, but they're not really headline products. I mean, that would probably change quite a bit the focus of evaluation procedures, and probably we would need to include them really more routinely in our evaluation. So, as such, to go on this topic, CAMS 273 would like to see some evaluation and some uncertainties associated with these parameters, because that would impact a lot the results of their chain. And also, they would like to be sure that these parameters are made available in the next CAMS reanalysis, as apparently it was not in the current CAMS reanalysis. And also, they would like to ask for assistance in recomputing then SSA and asymmetry parameter from the current CAMS reanalysis, which could become possible from the processor that is planned to be developed maybe in the Cameo project. I mean, but that's a bit outside the scope of CAMS, let's say. So in this context, that's quite nice to see that SSA is evaluated from time to time, and it's quite nice to, it's fortunate that we managed to solve a bug actually in the 48R1 use of optical properties in the context of the preparation for operational cycle 48R1. So that's just showing here an example here of simulated NVS observed SSA at 440 nanometer with the bug on the left-hand side. That's round 3 pre-cycle 48R1 in forecast only, and after the bug was corrected on the right-hand side. So it's better to work with this than with this. Okay, so that's a short summary. Maybe Marion wants to add some items. I don't know.
I think it's fine. It's a new wish list from a lot of people. That's our role. But it opens the field for new evaluation.
And the rain has stopped, so.
Yeah, thank you for this nice summary. Unfortunately, well, I was in the other meeting, so but I think it's very interesting. Concerning the output parameter on new diagnostics for the comes analysis, so that's of course possible. The only thing is we need to know in advance what you want. So please put together your wish lists as fast as possible, and then we can require the crypt codes and make sure that we output the data if it is possible. So, but we should start early, and yeah, that's one comment. And the other, maybe the question comment is, I think it's very good that, or it's very interesting that you have the intention to go more to optical sort of output directly, that the optical properties of the IFS is used. The only question I have is there maybe then a danger that it's sort of fixed, that you don't have the flexibility anymore to change it and to experiment with this? Was it sort of a thought you considered?
Well, the background is what we're doing currently is something like 0.2 times AOD of dust plus 0. Something AOD of this and that equals opaque type insoluble. And then we would need to fit that all the time when you do major changes in the optical properties, or then new components are included. And I mean, first of all, we know that the opaque component description is outdated with terms of hematite content, with terms of diesel or biomass soot properties, which are all this mixture. So why should we stick to this old description and then fit empirically more or less to what you do as direct model output? And then you have a new cycle we need to update. And I mean, isn't that just stupid to go this way? So the idea is to be more direct following you. That means we are more dependent. We leave control. We cannot correct if we find any biases. We will then really rely, or we would need to have a bias correction on G or SSA space, yeah, which, well, I'm not sure, I've never thought about, yeah. Yeah, we rely more on the IFS by that, but we are CAMs. That's why it's okay, I guess. And we hope to profit. But the challenge is really, I mean, if Marie, yeah, that was your message. Our current McClear version 3 is hard to beat. So a good challenge. And we are not saying we go for version 4. We say we evaluate that, we develop and test it, and we hope it's better. We'll see. We're talking about evolution, not update at the moment.
I mean, a general conclusion is that maybe the optical properties could be reviewed, not just for the IFS, but sort of also in the system, or in context of the regional models. We had this discussion yesterday as well, that the regional models also have certain assumptions, and if we can come up to a common best conclusion, this would be nice. And also what you pointed out here, this process of that you use data early, we discussed it yesterday as well for the regional models for the boundary condition. A similar process could be implemented also for testing of the boundary conditions before the actual implementation of the cycle.
Okay. I think we have one more question in the back, if I see correctly. But wait for the microphone for the online people, please. Sorry. Oh, I made the mistake myself. So.
Hello. Okay. So are you linking the new SSA to the photolysis routine? For the chemical feedback, because the photolysis routine in the scheme accounts for the single scattering of the aerosol. So if you're altering the single scattering, then you could make a direct link between the new single scattering albedo and the photolysis routine. Is it already linked in the code?
Okay. Well, Vincent probably knows better, but I think the SSA is already used in the photolysis routine.
It is linked to this. Yeah.
That's a purely IFS question, I think.
Okay, I think that we have finished. Maybe we can also go outside. It's not raining so much as before. Thank you to the speakers, and thank you for you. to you and see you in to the icebreaker. No, it's